till now we have covered till the single thread nature. So why it's pretty much very easy to build a node application very fast and in a scalable way. And we have multiple companies, Netflix, Uber, PayPal and eBay, using JavaScript as their or Node.js as their main building block of their company. And yeah, npm is a talk of the hour. Yeah, so now I would just go, if anyone knows what is the long form of npm, they can just put it into the chat box. But many of you would be knowing npm as a node package manager. But if you go to the npm long form to the GitHub repository, the first and the foremost thing which you would get, that npm's long form is not node package manager. Okay, so this needs to be very clear in your mind, that whenever I say the node package manager, it is not npm. Okay, so npm is, they have explained it right there, that npm is something, the precursor of pm, which was a previous command, all these things. So first of all, make it clear that npm is not node package manager. This is a fact which 99% of the people don't know out there. And we are discussing these things because we want to get above the competition, right? So yeah, but npm, what the exact use case of it is, it basically manages the packages for you. The dependencies are managed by npm. Npm as it is. So you can just go to the GitHub repository. We have some 12,600 odd commits out there. So you can just check out how this npm works under the hood. But in today's lecture, we have more of focus on the Node.js part. Okay, so why or how do we use Node.js? Whenever the database behind is NoSQL, preferably, we have some ORMs which do give you flexibility to have SQL in place. Then we can have data streaming, we can have chat application, but server application. But the main con out of it is that we can't have CPU intensive work like image processing, cryptography. We also can have, we can encrypt out data, but we can't host a server to just be focused onto the cryptography altogether. Okay, so Shailendra, you have raised hand. Yeah, you can unmute and just speak out. Yeah, Shailendra, you can go ahead. Want to speak, you can. I'm not audible. Just a second. Okay, just feel free to talk whenever you want to. Okay, just move ahead because you have a lot to cover today. Yeah, next topic is synchronous versus asynchronous. So this is the main topic which would determine how well you understand the next maybe 40 minutes or so. Okay, so whenever I say synchronous and asynchronous, it is basically similar to, synchronous is basically similar to blocking and asynchronous is non-blocking. So it is as simple that let's say my code is running line by line. One code comes in between, or one single instruction comes in between, that demands my processor to stop right there and not move ahead till the 10 minutes is completed. That is blocking code. In this case, we are using a fs module. Fs is a file structure module. It is an inbuilt module in node or in javascript, which helps you to read files. Now if you're able to recall some previous topics which I talked about right now, that node is based on javascript, and javascript is very good in understanding the dom elements, right? But dom elements are in the browser. They don't have the access to get to the file structure and then talk to the file structure as a whole. So I previously talked about, just a second. Yeah, I previously talked about the difference between the DOM and the APIs which we provide in Node.js, right? And for that, I guess I would just first cover the later part of this and then move on to the, yeah. So this is the entire architecture of Node.js. Okay. So Node.js is basically made of two parts broadly. First is the V8 engine, which was taken out from the Google Chrome. This is the JavaScript interpreter. Okay, interpreter, call it execution engine. So V8 is the whole and soul of this particular Node.js runtime. Okay, what libuv does? Libuv is based on C++, so it gives the file structure, the FS module which you're looking right now is basically provided, that API is provided by Libuv because it is based on C++. It is easy to access file systems out of it. All the IO operations, all the thread stuff, all the process stuff is taken care by Libuv. Okay, so this is the structure which the entire Node.js work. We will not take a lot of time discussing on the HTTP parser, CS, OpenSSL, and zlib because these are not that important. They play some peripheral but important roles. And but in today's lecture, we're discussing more about libuv and v8. Okay, so there is one more important concept called as event loop and thread pool. Okay, so right now we are very much clear that what v8 does. V8 takes in JavaScript, it turns it into a executable stuff, not executable file, but it basically understands JavaScript. Libuv doesn't understand JavaScript. It is C++ based, but it gives the entire kernel level access to JavaScript engine. When I say kernel level, so basically we interact between the interaction between software and hardware is done by the kernels, right? So this interaction is taken care of by the libuv. Okay, so till now I guess you are with me. We have a thread pool, you have event loop. I know these terms are very heavy at the first place, but we would break it down and then understand. Okay, so what happens is I would just go to the drawing which I had. Yeah, so this is a very brief, or this is very high level design of how what Node.js works. So let's say now you are a client. Okay, client, it can be anything. You are building a very big system. Maybe you are building the next Uber out there. Okay, now you want to access or fetch data from my API. Okay, now you give some hit to the Node.js server. This event loop is nothing but you can take it as an infinite while loop. Okay, what this event loop has to do, basically it has a structure. Okay, we'll get to the structure also. So this is what the event loop exactly looks like. This is the life cycle, or how the template, or this is the format in which the event loop works. Okay, so right now just take into consideration that what event loop does, it basically takes all the data, because we can have multiple out of it, right? We can have tens and thousands of instructions. I would just go to the code and show you once that how this file might look. Okay, just a second. Okay, so this is the example code which would be looking in the coming time. But yeah, so this is the code which depends upon how you write, how you want to design your app and all those things. But this is the entire code. Let's say a 50-line code which we have right now. So it has some different instructions. We have some read file instruction, console.log instructions, and all these things. Okay, so there should be some life cycle to it, right? There should be some order to it. How would the engine know that, yeah, I have to execute this line first? Because when the engineers were designing Node.js, they had a fixed set. They had a fixed mindset basically to, yeah, we have to prioritize a particular tasks first and then execute second. Because every time when softwares are designed, we do have some high priority tasks, we have some low priority tasks. So in order to fulfill that, the event loop was designed. So what is the exact use case of event loop is that it gives a structured way or a structured steps in how the engine would perform or how the engine would go forward. Obviously, for every core you do, you have some steps, right? That let's say you have to make tea out of, or coffee. You boil milk, then you bring the coffee, then you put in sugar. So these type of steps are basically put into the engine first, that you have to follow these steps, and then the engine follows these steps. This was made at the time Node.js was built. Okay, so this event loop nothing but kind of a SOP, you can say. These are some steps there. So what it does, it goes through the code completely. It checks out some different steps and then starts to execute that particular program accordingly. So now just keep in mind that this client is basically again the thread which we talked about previously, right? So we had a thread right here. So this is a single thread which is coming onto the, just a second. Yeah. So all these requests are coming through a single thread to the Node.js, and each process, let's say F1, had some different steps. We can have 15, 30, 70,000 of lines of code, but these is broken down into some steps, right? That how do we want to break it down? So once the event loop starts, now I'll just go back to the PPT and show you rest. Yeah. So I guess now the very basic of event loop is clear. That why do we need an event loop? It basically, this is a template of how these steps are executed. We'll come on to what thread pool looks like in the next part. Okay. So we have a Node.js process or instance running. Let's say whenever we type run command, this Node.js process is instantiated. Okay. Now this single thread, we have a single threaded nature of JavaScript. Each process comes to the thread. What happens is we have a sequence of instructions being executed. So this sequence is nothing but the event loop. Okay. So we have some different, we initialize program, we execute top level code, then we require modules. You did not learn this, but this is the life cycle. We register some event callbacks and then the start event loop starts. And we have something called as offloading. So just try to digest this right now. Okay. So what happens is whenever this event loop comes into picture, just a second, yeah, this slide. So where's the, yeah. So let's suppose my new program comes in. We have these steps. Let's say we have 5 steps in place: step 1, step 2 till step 5. Now this event loop starts to do these steps. This event loop has no other work than to just assign the given process some hardware required in the processor part. Okay. So now event loop is done. Now next comes the thread pool. So before coming to the thread pool, I would like to again go back to the synchronous and asynchronous part right away, so that now we are clear and ready to move forward. Okay, so synchronous, basically I talked before that the code is stopped right there, and asynchronous is when the next part of the next line of the code is still running. Okay, so this is what there's a difference between the synchronous and asynchronous nature. JavaScript was built on the basics or the principle of asynchronicity, but we can also use synchronous keywords right there. If you want to see how this particular thing works, I have a sample code out there for you guys. So now you can see I have a code of synchronous execution, or maybe I have this small code which was set ready. Mm, okay, let's start that code only. Okay, so in this particular code, I would like to bring your attention to this line. So first we require a module, then we log a particular instruction. This is a synchronous instruction. Then we go to a callback, or we are trying to basically read a file. Again, this is synchronous instruction. Then every time we try to access a different uh, let's say data through it, either it is synchronous or asynchronous. Okay, so in this case we are using a special function called as read file synchronous. Basically this would block the code right here. Okay, but this can have different behavior because it's inside the callback. We would get into what these callbacks, how these works and all those things in the coming part. But yeah, so what I have to bring your attention to is that synchronous code would block the uh, execution in that particular line of the code itself, and asynchronous would let the code go, or the let the engine go to the next part of the code, run that till the time my particular code output is ready. uh, Once it's ready, then the output would be shown instantaneously. So all these things are taken care of by the event loop. Okay, and now what happens is the difference between synchronous and asynchronous in JavaScript is that whenever JavaScript gets a blocking code or a synchronous code, it basically tries to offload this particular thing to different threads. Now, you might be, you get this question that what if JavaScript is single threaded, why do we have a thread pool altogether? And why I'm talking about threading right there. So this is the superpower given to Node.js by libuv. Okay, so libuv, basically I told you it's C++ based. So it offers a thread pool. So this particular thread pool can go from 4 threads to 128 threads, depends on the system which you are running your uh, Node.js environment to. It can be having, by default it has 4 threads, minimum 4 threads, and maximum 128 threads. Okay, what do I mean by threads? Threads are basically multiple pathways of you executing the code. But in JavaScript, by default, it happens that whatever heavy or CPU intensive code is running, it is basically running using this particular thread pool. Okay. Now let's say you had some you wanted to encrypt your password. Okay, you have a server whose main job is to encrypt the password which you have onto your server. Okay. So encryption or cryptography as a whole is a CPU intensive job. So what this particular event loop would do, that it will first sense that okay, this particular instruction has this cryptographic uh, instruction in place. So now the server would offload, or offload means that basically it would direct that process to go to a different thread altogether. So let me first make it very clear that the entry to the Node.js runtime would always be single thread. The event loops take care of which entry to or which process to direct to a synchronous nature or a synchronous nature. So the programmer basically directly assigns or tells the computer that okay, this is a particular synchronous command, or this is a particular asynchronous command. So if you know something about promises or async await, so async await is asynchronous in nature, so that doesn't block the code, and because of that this event loop doesn't direct that particular process to the thread. So if it is a CPU intensive job, we would move, or the event loop would move that process to the thread pool, and then this thread pool is whole and sole responsible for execution. Now I have a really good example out there. There's some chat, I guess. For us, because working, it's compulsory to have different threads. So see, asynchronous working, it completely depends on how the process wants to run. So if the CPU or the event loop thinks that it is very, very process intensive, then it would directly give a complete different thread to it. So it depends on to the kernel system or the operating system also. So in AWS, we have something called as virtual machines. So we have hypervisor sitting on top of the operating systems. So it again depends on to the nature or the Linux or the Unix system which is being provided, the kernel which is being provided. Okay. But in this particular thing, whenever we offload tasks, can we have asynchronous nature in single thread? Yes, we can have. See, it depends. See, whenever we have IO operations which are process intensive, so how much it is intensive or it's not intensive, it depends on to the how the event loop is programmed to do. We have something called as mm, a charts or some timing charts, which is given, or the timeouts basically given to the event loop, that if this time frame, the particular task is not completed, we categorize it to be a server intensive task and then redirect it to the other thread. So all these comes into operating system. Let's not dive on that particular side. We are trying to understand how Node.js is working under the hood. Okay, so for this, for you guys to understand, I have a really good example in concurrency there. Okay, so yeah, I am introducing you to a new term called as concurrency. Okay, so I would just first tell you what the difference. So now there can be two broad ways to execute a program. Okay, or to execute multitask. So Node.js can handle multitasks, right? So let's suppose I have my processor sitting here between, and this has to fulfill any task. Let's say now I have 10 tasks, or let's say for sake of simplicity, let's suppose I have four tasks. Okay, I have X, Y, Z, and A. Okay, I have these four tasks. So we have two ways of doing it. Either you take it in parallel nature. What do we mean by parallel? That all these would be given access to the system directly without taking into consideration what their priorities are, what their requirement of systems are. Okay. So yeah, so we have different threads altogether. Just a second. Right. Yeah. So this is what parallelism means. Now let's say this particular, all these have some same compute time of maybe 10 milliseconds. So in parallel nature, all these would be completed in 10 milliseconds. But now in concurrent, what happens is we have some context switching in between. That this would now again go to a single queue and then it would be processed. So concurrency means that we can have context switching in between, but it would be through a single queue or single thread. So again, it depends on to how the languages are made or how the runtime is planned to do. Okay, so yeah, now I will just explain you the simple code which I'm doing. I am installing a dependency called crypto, which is basically trying to encrypt and add salts to your given data, basically acting kind of a password key. And now in Node.js, we have this particular environment variable, which is very much useful, called as UV thread pool size. So by default, it has a 4. It has a 4 as the assigned value, that it should have 4 threads. Now what I'm trying to do is I'm having a function called as perform task, which does nothing but to encrypt a particular given string to and then generate or return a different key altogether. Okay, and now I would be looking onto the time frame which this particular thing is working, or how much time it is taking. Okay, now I would just run this file. And now, okay, now just see. Okay, so it's giving me thread pool size is 4. Task 1, task 2, task 3, task 4, all are started right now. Okay, but the completion time all started at the same time. And the completion time, almost every task has been completed at the same time. Okay, around 35 milliseconds. Because we have 4 threads in place right now. Okay, what would happen? Now let's say I have 4 threads and I have 4 CPU intensive uh, jobs in place. So what the event loop did was assign each thread to a CPU intensive process like this cryptographic perform task function. So each of this perform task function signified a different thread here. So X, Y, Z, and A. So it started all together with this nature that okay, so this is a particular heavy task, assign it to a thread. Now what would happen if I try to increase the number of process to, let's say, 5? So what according to you guys would happen? If you want to, you can add it in the chat box, that what the behavior should be. Should it end at the same time as these end, or should it be something different? Okay, now I would just try to run this again, and then you just see the difference. Okay, so this again finished somewhere around 35 milliseconds, and but this took around 70 milliseconds, did double the time which these things had. Why this happened? Because all these threads were busy. The event pool had 4 threads, right? The thread pool had four threads. What the event loop did was to offload these heavy tasks to these 4 different threads, and the fifth one still waited here till the time all these threads are empty. So the moment one of these threads got empty, the waiting process again went to that particular empty thread, and hence all these took 35 milliseconds. But and then the additional, which let's suppose the B tasks come into picture, which was waiting all the time till these were executed, and then it started its process. So if you're able to see, task 4 was completed at the first place, 36 millisecond. The moment this task was completed, the event loop assigned the empty thread to task 5, and then the execution started. Now let's suppose I make this number to 8 and reduce this thread size to 1. So now what happened is we have reduced the number of threads to only 1. So now we only have single thread in the thread pool. We can configure it as and when we want it. So my PC has 8 cores, so I can add many more threads also. But now, for sake of explanation, I have made it to a single thread. So what would happen? Only one task can be completed at the single time. Okay. So now I run this. So you can see what happened just now. Task started, and in the same order they ended. Why? Because all the tasks which started 1 from 8, they went to the event loop. The event loop got to know that yeah, these is some heavy tasks. It offloaded it to the thread pool, but the thread pool had only one thread, so only one task was to be executed at the single time. So whenever one task was being executed, the rest waited for the execution. So you can see that almost 30 on the jump of 35 we had the task completion milliseconds, right? So now if I try to again, we can play around with it. We can have two threads and we can have uh, 16 tasks. Now I guess the times would be again same, but in the multiples of two. So first and if 1, 2 got in, then 3, 4 got in, then 6, 5 got in. So we can change it as and when we wanted to. So this is the entire architecture of how Node.js offloads the heavy tasks to the thread pool. So what is the thread pool exactly? This is the libuv. So libuv is a open sourced library or open source tech which you can just go to GitHub repository and read its readme or just go to the code entirely. So it is C++ based, which is doing all this stuff under the hood. Okay, so I guess this particularly clear. The all the events or all the requests come through a single thread. It goes to the event loop. The event loop has some steps which it has to follow. These are the kind of discipline which the event loop has. Now, if the event loop senses that this particular task is heavy or this is synchronous, this is blocking, it offloads that task to a complete different thread. Okay. Once this thread results comes back, let's say this thread now is busy, all the processes still wait, all the heavy processes wait till then. Okay, now let's suppose, okay, while we're executing this, we want to again console.log system. So it would be easily be working. Okay, so this is again a really good thing to test. Now, this is a code wherein I have a combination of different callbacks, a combination of synchronous and asynchronous code. Okay, so we have a read file. This is a asynchronous IO operation. We have a synchronous IO operations. IO operations are quite heavy, uh, so that's the reason I'm using this. Then we have a promise. Then I have again I'm reading it using a promise. Okay, and then I have a async function, and then I'm logging it. So now I would try to run this particular file and I'll show you how this particular thing works. Okay, so before doing this, I would just go to the life cycle of how these things work. Okay, so this particular part is ready. Yeah, so this is the advantage of the asynchronous nature. Okay, I would get back to the code again, but this concept should be cleared first in your mind before you move to the code part. Okay, now let's say you all of you guys might have used Book My Show or any ticket booking systems like IRCTC, right? What happens is I would just tell you the actual use case of threading. Okay, let's say I have my server or my railway server. I want to book tickets. Okay, now only single ticket is left. One ticket is left in my server, and at the same time, I am having multiple requests to the server trying to fetch the single ticket. Everyone wants to go to Bombay, let's say. Okay, now I have four users. Four users trying to hit this particular API from four different directions that I want this ticket. But my software, it should be designed that only single should be allocated, right? So the exact use case of this is or the multi-threading is, so JavaScript is single threaded, right? Let's suppose all these four users, uh, okay, let's just give you an analogy. Okay, I have a room wherein I have four doors, and anyone can, so four people can come in at a time, or multiple of them come in at a time, right? No need of a queue. Minimum four people would come to the room, right? So this is what multi-threading is. So this can be in the case of Java. We have Spring Boot in place. We have C++. All these are multi-threaded in nature. That we have to then keep into mind that which data structure is thread safe, which is not thread safe. So all these things would take into consideration when you're building apps in Java Spring Boot. That is the reason these softwares are very intensive to learn. So but in the case of JavaScript, we do not have this headache, right? We can simply delete all these. Just a second, yeah. And we have a single customer or a single line coming each time. The first one who comes, we can give the ticket and our job is over. We not have this headache of which thread to go first, which thread to not go first, right? So this is the main advantage of Node.js. So if you're not going to use very CPU intensive tasks, Node.js should be your go-to option for building any app out there. Okay, so I guess everything is clear till now. Okay. So yeah, this was the example to do. Now let's say we have multiple requests to our app. One is trying to read some last text file, one is trying to log in, some is requesting data, and all these things. We have a single thread nature. Only one person would come in at a single time. So I also there are ways in which you can also increase this main thread also. But if we are trying to show you a single JavaScript or single Node.js process, take just engrave it in your mind that we only have single thread as the main thread or the primary thread. The event loop has then the flexibility to offload these tasks to multiple other threads also. Okay, so keep in mind that for when a single JavaScript instance is running or single Node.js instance is running, we do only have single primary thread and some worker threads, which is given by libuv. Okay, so it's completely clear right now, I feel. Okay, so it's your job as a developer to avoid this kind of situation wherein we have a synchronous way to read a file. Okay, what would happen is, let's suppose now all these requests are coming into picture and we have this kind of coded in our API wherein we are blocking my API till the time my request is completed. What other way should be that we use a asynchronous way? What asynchronous means that this data would be offloaded, or this would be given to some different worker, and till the time that particular request is completed, other requests would also be fulfilled till then. So if you are using Node.js, you have to write asynchronous code. You cannot block your API. That is the worst mistake you could do when you are using a Node API. Okay. So yes, so these things are done. So yeah, this is the better approach of using this particular Node.js environment, that we are using a non-blocking code execution. So all this task of reading data would be done in the background and not blocking any other user. So with advantage or the high grounds of giving a single thread, we also have this particular shortcoming that we have to write asynchronous code as much as possible. Okay. So, okay, this is the some coding practices. So whenever we try to nest some callbacks inside other callbacks, we get a callback hell. We not go into this particular part, but if you want to know what exactly a callback is, so just make it very clear that JavaScript is a callback based language. Okay. So whenever you say JavaScript, it's always a callback system. What callback exactly is, that it is a function assigned to a particular event. So event can be anything in a programming language. It can be as small as reading a file to as large as processing a complete machine learning model. So events can be anything. So callbacks are basically some functions which are triggered when a particular event occurs in the Node.js runtime. Okay, this is the function, or this is the very layman definition of what a callback is exactly. Okay, so if you read any kind of documentation while you're using Node, you have to have some using dependencies. You might be coming across some callback functions. So callback function nothing, but whenever a particular event occurs, you do a particular task. That is a callback function. Okay, so okay, I will not go into this particular part. I will just go to, yeah. So we were here, right? So what we understood till now, that we have something called as event loop. The event loop takes in processes through a single thread and it offloads some heavy processes to the threads to complete and then get back the results and then show back it to you. Okay, so what these handle heavy or expensive task looks like. So it is like file system APIs wherein you try to access files through input output. We have cryptography, which we looked forward right now. We have some compression. Now let's say if to compress a file, that's a very heavy tasks. So that is also categorized on the expensive task. And we have DNS lookups. So previously I showed you something called as HTTP parser, right? So this is some network calls which are made to the HTTP. So these are DNS lookups. So DNS lookups are basically when you try to map a IP address to a website, that takes a very long time, around some seconds. So seconds, 1 second is also a very expensive task when it comes to a processor runtime like Node.js, because all these things happen in nanoseconds and milliseconds. Okay. Uh, so the Yeah, so the heading, the heart of Node.js is the event loop. Okay, because this event loop has everything to do with your Node.js, and this event loop basically is the reason Node.js became so popular, because the event loop prioritizes your tasks to any particular means. Okay, which is not very common in other runtime languages. Okay, so the application code that is inside callback functions, non-top level code. Okay, so let's not go in this particular file because I've covered it right now itself. But yeah, node this is built around callback functions, which means that every event which occurs in node.js is assigned to a particular callback. So whenever, let's say, my particular job or my particular execution is completed, we move to the next part, right? So then moving to the next part is also a callback. Then that's all about the callback functions. Okay, we have event driven architecture. What is event architecture? Whenever I say we have asynchronous operation, what exactly happens? Okay, let's say I have some code which is asynchronous in nature. I have some async code right here. Okay, now it has a task to maybe fetch something from my database. Fetch database. Okay, what it would do is basically altogether start a event based function or event based callback till then, and then the next line of code would till then be executed. Okay, we can have any n number of lines. Okay, it would be completely executing all the next lines till then. What happens is whenever this fetch data is ready, okay, whenever this fetch data is ready, a callback function is called. It can be as simple as a return statement. Okay, when you say return data, this is also a callback function. So what happens is whenever this return is also called, let's say data comes to my server from the database, and now I want to show it to the or give it back to the client, and we are rewriting it to be asynchronous. So whenever this async is called, the process goes to the background. If it's heavy, it goes to the thread pool. Okay. Now what happens is this event is when the event is called. Okay, so we have something called as event triggers. Okay, so it is nothing but if you guys know something around interrupts. So interrupts are very common in uh, core computer science fundamentals. So these interrupts are nothing but some hardware kind of a things on the top of which this Node.js event-based architecture is based. So whenever any change or the result of a function is arrived, we emit something, or this function tries to gain attention, and then we change the context, and then we have the data ready. This is all about the callbacks. Okay. So event it means that events are emitted. When I say emitted, it can be as simple as return statement. When I say event, see, when what the event loop does is, yeah, this is the most important slide if you want to know about event loop. Okay, so every time, so I talked about some steps, right? So these are the steps which the event loop has. The event loop starts. If there are some expired timer callbacks, they are first executed. Then the IO polling is done. What is IO polling? Basically, if you want to read file, if you want to write file, if you want to fetch data, all these things are comes under IO polling. So first, these are the steps, and every time the loop runs in this particular manner only. So what is this exact loop which I'm talking about is this. So we're talking about event loop all the time, right? So this event loop basically has these steps. So every time this loops runs, first it checks for some expired timer callbacks, that if there is some timeout function going on, it will first execute that. Then it would implement the IO polling. IO polling nothing but try the input output, the read write statements. Then we have something called a set immediate callback functions which are executed. Then if there is something close, like we are trying to close the connection to the socket, if we're trying to close the program, then the close functions are executed, and then it checks whether my particular program now is completely executed. If not, it again goes back, and then again this cycle starts. So this cycle is kind of an infinite cycle which goes on completely in the event loop. In between of them are the promises. So all the async await, dot then, So all these, the try catch functions, all these are executed in between of these phase changes. So we call this as phase. So you can also call this to be a queue. So whenever the program starts to execute, these four categories are the broad categories inside which all the executions are queued onto. Whenever the event loop arrives at this particular phase, it first either tries to exhaust this particular queue, means it tries to run all the possible events which we right now have, or there is a timeout. If the timeout is reached, we again move to the next phase. This is the entire workflow of this event loop. And in between the transition of these two phases, we have something called as micro tasks, which are the promises which needs to be resolved. Okay. So now let's say my event loop is right now we are trying to access some data. Okay. Now while accessing the data, I got a asynchronous promise. Okay, now I move to some set immediate callbacks. When I'm in the set immediate callbacks, it can be anything. Okay, set immediate can be as small as getting some event through the OS. One try to join. Okay, and in between these two, let's say my data arrives from the database. So in between these two, my promise will be resolved. And there's something called as next tick, but it comes when you are using Node.js to a very intensive job. Okay, next tick is some small process which needs to run when there is a phase change. So as of now, I have never got a you know real life use case of implementing this process dot next tick queue. But this was made, obviously when the language is made, you need to take into consideration each and every part of the implementation. So we'll not talk about this particular thing right now because it's out of the scope of this video. But yeah, these resolved promises are always taken into picture or executed when we are trying to move from one phase to the other phase. And once this entire program is done, then the event loop exits, which means that what happens, we executed this code, right? We executed this code. So whenever this particular line ends here and then we come here, the event loop exits. This is what I mean to say. Okay, now this is a very simple code. I would just now try to run this. Okay, what app.js, right? Okay, so I have a file called example.txt which has this hello world, how are you? Okay, this is printing out here. Now I would just first go to the this particular slide, and I'm just able to split this screen up and then show you style window over here and next here. Cool. Okay, just a second. Hmm. Okay, I'll just put it side by side and then try to run it. Just bring it down. Okay, done. So what happens is we first try to run the expire timer callbacks. So this particular code doesn't have a timer. Let's say if we have try to run some timer code, we have next tick, we have read stream set immediate. Okay, this is the code which you're looking forward to. Cool. So now I will just run this first. Okay, so this is how this program is executed. Now just look here on the left side of the screen, and then we would simultaneously try to gauge that, yeah, if it's working in our code or not. Okay, we start with requiring a module that is initiated well before the event loop starts. Then we have a simple console.log system that the process starts. This is the top level code. So take into consideration that event loop starts whenever the code is inside a callback, or either we have a set of code, or else if the top level code has nothing to do with the entire logic. Okay. So now what we can do is see program starts, program ends. So you can see this program starts right here and this again ends right here. This is first of all printed right away. Why is this? Because this is the top level code. Top level code is always executed first. Just take into just keep in mind that particular thing. Okay, now while we do this, we have some process dot next tick into picture right now. This is whenever we are trying to switch different phases. Now what is happening is that our file is taking a bit of time to load, and hence till that time the timeout exhausts and it moves to the second part. When it tries to move from one phase to other, this next tick instruction, which was right here, is executed. Okay, then the promises are resolved. Why the promises are resolved? Because again, next tick and promises, both of them are executed when we're trying to change the phase. So when we're trying to change the phase, both of them are executed. Okay, so till then we are clear. The synchronous program top level code executed at the first, then the next tick. Okay, so if this particular phase, any phase, okay, was light enough to be implemented or executed at the very fastest of amount of time, we did not switch the phase, right? If this phase was not switched, we did not execute, or the engine did not execute next tick and resolve promise. But this was done because our uh, processes were quite heavy this time. So first the top level code executed, then the intermediary or the inter-step processes executed. Now you can see this particular flow. First of all, the expired timer callbacks. Okay, so we have set timeout to 0 in this particular case. So this is the expired time, right? This is the expired timer at the meanwhile. So it's been executed. Then set immediate. So set immediate is being used as a IO here. So we had some IO there. Just a second. We had a stream. We are next to them. We promise. We had a fs.read. Okay, so we had IO being executed, but it took time. Now it depends because it is not inside a callback. Okay, so just a second. Okay, so we have a set timeout being executed, and then the IO polling. So this is the exact flow which I'm trying to show you, that this particular flow is always followed by the engine whenever it is used inside our code. So whenever there is some abnormalities in the engine, we can easily figure it out using this particular map. Okay. So streams, okay, we would wait back to what the stream exactly looks like. So I guess it's quite clear till here. Okay. So okay, so summary of the event loop. Why Node.js is, if why should you use Node.js? Why should not use? So in cases where you personally feel that Node.js, that we have some light operation, we don't have very CPU intensive jobs like cryptography, like file compression, all those things, we can use Node.js altogether. What Node.js gives you a single thread. So the difference between Node and some different languages like PHP and Apache is that whenever a new user arrives to your API or your server, Node.js would queue them up, okay, one after the other. But what these PHP Apache would do, they would create a new thread altogether. So then we at times have some weird behavior in PHP and Apache because some same data structure is being used by 10,000 different users. So this is not the case, right? So if we have one ticket left and if it is booked by 10 other people, it would create a business nightmare altogether. But Node, this would not happen with Node, right? This would queue up all the users in a single queue, and the first one would uh, get back the ticket. Okay, so the main thing which you should take into mind is that never use sync versions of your functions when you are inside callbacks, particularly when you're using these type of modules. Be careful with JSON in large objects. Don't perform complex operations. Like don't have nested loops in JavaScript because it may make Node.js work weirdly. There are cases in which JavaScript works really weird, so some part is still yet to be explored by us also. And don't use too complex regular expression nested quantifiers, which the callback I've talked about previously. Okay, now yeah, this is the event driven architecture which I talked previously, that we have some emitters. The emitters emit some event, and there's some listeners which listens to the event. So this is kind of a pub sub model which we have. Not exactly pub sub, but yeah, one emits and one catches. And what are these emitters? These are basically the async code which you write. And what are this listener? The async code which you write. Okay. So the async code which you write creates a event emitter and the same catches it also. Okay. And the callback function which we had is the basically the next part, or whenever a particular event occurs, the event is emitted. we cache that particular event, and then subsequently the callback function is called. This is the entire summary of Node.js. Okay. For example, we have, let's, this is the socket, a very typical socket. Okay, socket is a duplex connection between the client and the server. So in this case, we have a server localhost 3 at point 8 port 8000. It has some request event now. Okay, so server dot on request event, we have a callback which takes in some request and response, and it console dot logs request received and then sends request received. So it is a very naive socket which does just on a particular request event sends a text request received. And this is a very solid example of how the event-driven architecture works in Node.js. Okay, so I guess we are done with the time. We will discuss about streams in the upcoming lectures also, but let's just first clear these all parts which have completely done or covered, right? So yeah, if you want to talk about the V8 engine, so V8 engine, it's responsible to just parse and execute JavaScript code. Okay, it has the DOM in place, but the V8 which we see in Node.js, the DOM, we don't use DOM there. Okay, we have some elements called as pug and all those, but let's not get there because server-side rendering is completely different subject altogether. Okay, so this is the description about some of the tasks which you have. And yeah, I guess I've completed all. Yeah, I've tried to cover each and every part of what I plan to. Streams and all, I would cover it in the next part. We have a lot in place. We have expressed the X architecture. Okay, so this is for some high level, like so if you know about Express, you obviously you have heard about Merge stack, right, in which we have Express as a thing. So Express is just a wrapper over Node.js. It gives you more flexibility to focus on the business logic rather than getting into these technical intricacies altogether. Okay, so I guess we have covered whatever I wanted to cover. Okay, so we have done with the lecture. If you guys have any questions, the platform is open for all of you to answer, or sorry, all of you to question. Yeah. So first of all, thank you, Gauri, Priya, Yash, and Shailendra for being here. Uh, you can ask any questions if you want to. If you want to add in the chat box also, you can do. Yeah, Yash is typing. Okay. Let me just revise these topics. Difference between Node and Express. Okay, so see, I would just go to the slide directly. Just a bit. So see, Express is kind of a wrapper sitting over Node. Okay, so if you go to an Express website, it is giving you Express is a minimal Node.js framework, a higher level of abstraction. So what happens is whenever you try to use Express, you get some functions which are previously written by some developers. You just call that function. You need not write Node.js code completely. Okay. So we have some complex routing, easier handling of request response. But let me just read this till the time I would just bring you a sample Express app which I have developed recently. Yeah. So MVC architecture is basically model view controller architecture. Okay, so I'll just show you directly the code. So what happens is Node.js is a runtime and Express is a tech stack built or a technology built on Node.js. Okay. So Node.js basically execute this Express code. Just a second. Okay. This is the sample Express API if you want to show. Okay, so this is a very minimal code. Okay, so we have app.listen. So what this does is basically creates a port 4200 and then exposes your web server to it. Instead, if you had to use Node.js, you had to write or you needed to write tons of codes out there. Okay, if you go to listen now, then you can see all this particular thing is written in TypeScript. It can be JavaScript also. But just to give you a very layman approach of what Express is, it basically a wrapper sitting over Node.js, which makes your life as a developer very, very easy. Okay, so you need not like, okay, so let's talk about something, why we had C++, right? We had assembly code. So assembly code was very tough for normal developers to learn. We can't have this move add instructions written all together, so we introduced C++ was giving us loops, was giving us conditional statements. Then we developed something like JavaScript on similar lines, which was used by Node.js. But obviously we can't use functions like which I showed before, set immediate, set callback functions, all these things. Now okay, uh, so this particular thing, right? We have these expired callbacks, polling, set immediate callbacks, some promises. This can't be written by developer like you and me every now and then, right? It would take us a lot of time. So instead, Express was created to make your life very easy. So instead of going into technicalities like read file, synchronous operation or synchronous operation, we have to use only listen. And now we don't know what happens under the hood. Okay, so all this function is taken care of by the Express. So whenever I say app.use, now what this uses, this is some handlers which are being used through TypeScript files, right? So TypeScript also again compiles back to or transpiles back to JavaScript only. Then the JavaScript is again executed by Node.js. This is the entire flow how it works. So we denoted this much code, right? So you can see this is a lot of code which the Express developers have written for us. So instead of focusing on writing this code, we just call a single function here, and then the entire uh, API is ready. So in my next sessions, we would be developing the API. We would be trying to implement business logic of how to query Mongo, how to send data back to React. So this is what actually developer needs to code out. Okay, we need not go to intricacies, but this today's session was only focused on learning the intricacies or technical intricacies, diving deep inside how Node.js works under the hood. So Express is not another, no, Express is not another language. Okay, it is basically a wrapper over Node.js. It is JavaScript. See, if you see, this is Express, it is .js. So Express is basically a npm dependency. If you just go here and I'll show you. So Express is a dependency. Okay, if you go to a browser and just write about what Express is. Okay, I just want to see Express npm. So it is a npm based package. So fast, unopinionated, minimalistic web framework for Node.js. Okay, it is nothing. It is not nothing anything complicated. Okay, so it is a web framework. Node.js is a web runtime. Okay, so it gives us a very easy level to implement our code for UNS. Okay. Cool, Yash. I hope you got it. In my upcoming sessions, we would be discussing only Express, nothing else. Okay, we would be getting into very details of what Express functions are, why are they used, what are each function meant for. Okay, so obviously you can go to documentation and then learn. But yeah, so you can see we have different functions being used here. We have app.use, we have some, okay, let's not get there, but I guess you got the crux altogether, right? That Express is not a new language. It is just a wrapper over Node which makes our lives easier. Instead of writing 50 lines of code, we just write one function that app.use and our job is done. This is what Express does. So I'm just typing something. So till that, then if you have any questions, you can ask. You can unmute also. Yeah. I'm talking. I'm the only person talking from the past 1 hour. Can you share? Yeah, obviously. Okay, so if you want to just connect with me on LinkedIn, I will just share you. I will just DM me. I will share you the link of this PPT. I've not uploaded this PPT anywhere right now, but I can share the PPT. I'll just share my profile. I've yet to upload this particular PPT somewhere. I'll just do that and then we can move forward. And all this thing is, can I talk in Hindi? Yeah, yeah, definitely. Yeah, I feel I know Hindi भाई. हाँ, बोल सकते हो आप, कोई issue नहीं. Language never a barrier for me. Go ahead, Shailendra. If हाँ अगर आप like if you want to I can also talk in हिंदी मतलब मुझे आता है हिंदी ऐसा कुछ नहीं. Okay. And हाँ, I will just share this also. Just go through this link also.
आवाज आ रही है भैया?
हाँ हाँ चंद्र बोलो।
हाँ, मैं बोल रहा था कि मतलब बहुत बढ़िया पढ़ाया आपने, पर मैं क्या फर्स्ट में लेट हो चुका था बहुत, तो जो
हाँ
फर्स्ट
हाँ।
का था ना हाफ, वो कुछ समझ में नहीं आया था, तो आप
कहाँ
शेयर कर
से?
देते ना पीपीटी, तो मैं रिवाइज
हाँ
कर लेता आपके नेक्स्ट लेक्चर के लिए।
हाँ ठीक है, भेज दूंगा वो भी, और रिकॉर्डिंग भी है मेरे पास, लाइक आई वुड ऑल्सो अपलोड, मतलब रिकॉर्डिंग भी मैं अपलोड कर दूंगा। जस्ट लिंक्डइन पे मैं पिंग कर दूंगा, मुझे चलेगा।
अब रिकॉर्डिंग कहाँ पर रहेगी?
रिकॉर्डिंग मैंने करके रखा है, मैं उसको ड्राइव पे अपलोड कर दूंगा, या फिर हाँ मैं
ओके
यूट्यूब पे
ओके।
भी अपलोड ही करता हूँ, जस्ट इस पे भी देख लो, मतलब आई एम एक्टिव ऑन यूट्यूब। मतलब आई जस्ट स्टार्टेड, ये यूट्यूब भी देख ही सकते, इस पे आता है, लास्ट लास्ट सेशन का भी मैंने यहीं पे अपलोड किया था, ये सेशन जो लिया
अच्छा,
था।
आप वो सेंड कर दोगे लिंक, तो फाइंड आसानी रहेगी
हाँ मैं
ढूंढने
इसी चैनल पे अपलोड कर दूंगा ये आज का वीडियो भी।
में। ओके ओके। बढ़िया, पर बढ़िया आपने मतलब बहुत बढ़िया पढ़ाया आज।
हाँ थैंक्स लॉट भाई, थैंक्स लॉट। और देखो
मैं
जो
एक
लिंक
और
भेजा
था,
मैंने इस पे भी है, हाँ बोलो बोलो।
अगर मैं जैसे एनपीएम से जैसे नेक्स्ट का कोई प्रोजेक्ट स्टार्ट करता हूँ, और अगर फिर आगे जाके कोई मतलब पैकेज पीएनपीएम से इंस्टॉल करता हूँ, तो कॉन्फ्लिक्ट रहता है क्या बीच में
नहीं
किसी
नहीं
भी
नहीं
पैकेज
सी,
के?
जो पीएनपी एनपीएम है ना, ये सिर्फ पैकेज
हम्म।
मैनेजर्स है। ठीक है, इनका काम एक ही है कि तुम्हारे जो भी पैकेजेस है, डिपेंडेंसीज है, इनको मैनेज करना। अब वो डिपेंडेंसी उसके अंदर जो है वो सेम होना चाहिए बस, और उसके वर्जन सेम होने चाहिए, फिर कॉन्फ्लिक्ट नहीं देगा वो। तो
अच्छा
उसमें हमारे
अच्छा।
पास बाकी बहुत सारी चीजें भी है, यार्न एक होता है, वी हैव समथिंग, मतलब बहुत सारे हैं।
यान ब्रू एक होता है शायद।
हाँ ब्रीव होता है, राइट।
हाँ।
सो वो डिपेंड, वो तुम्हारे प्रोजेक्ट पर डिपेंड है, तुमको क्या यूज करना है।
ओ- और
वो
जैसे
पैकेज
अगर
मैनेजर है।
मैं मतलब फुल स्टैक कर रहा हूँ, तो इसमें जो नोड जेएस में बहुत ज़्यादा डीप में जाने की ज़रूरत है, या फिर ऊपर ऊपर से मान लो जो भी मंथ्स में पढ़ाते हैं तो ऊपर ऊपर से पढ़ाते हैं, तो उसके अलावा जैसे आपका वो होगा उसके बाद अब नोड नमस्ते नोड है ना, उसका है शायद, नाम भूल गया मैं उनका, तो उसको मतलब
अक्षय
लेने की
सैनी।
ज़रूरत है क्या? हाँ हाँ हाँ, तो उसको मतलब बहुत
सी
ज़्यादा डीप में जाने की ज़रूरत है?
देखो अभी कैसा होता है कि मतलब अभी जो मैंने पढ़ाया ना वो रियल लाइफ में
हम्म।
बहुत कम यूज होगा, ठीक है। बट ये हो सकता है कि गुड टू हैव होता है, आपको ये समझ
अच्छा
में
अच्छा।
आएगा तो आप आगे जाके बहुत जो यू नो बहुत टफ टफ जो रहते हैं, जैसे अभी चैट जीपीटी एक ऐप है, अब वो बनाना
हाँ
कोई ऐसा नॉर्मल इससे नहीं कर सकते हो आप। अभी कैसे होते हैं जनरली, 99% चीज़ें जो है ना वो एक्सप्रेस से बन
हाँ।
जाती है, जो एक्सप्रेस ने फंक्शन दिया उससे बन जाती है। बट बहुत बहुत रेयरली ऐसा कुछ एक चीज़ होता है जो हमको कोई भी कोड कहीं से नहीं मिलेगा, तो उस केस में हमें वो देखना पड़ता है एकदम अंदर जाके। अब जैसे कोई स्टॉक मार्केट का ऐप है, इसमें रियल टाइम में काम चल रहा है, ठीक है, अब उसमें यू कांट एक्सपेक्ट नोड टू गिव यू मतलब एकदम फास्ट कुछ ना, तो उस केस में लगेगा। बट हाँ, इनिशियल लेवल पे, फ्रेशर लेवल पे ये नहीं होता, मतलब एक्सपेक्टेड नहीं होता कि आपको पता चलेगा। तो आप अगर एक्सप्रेस भी सीख जाओगे अच्छे से और बेसिक थ्रेड भी आ जाएगा तो भी इट्स मोर देन इनफ। ये सिर्फ
ओके
जिनको
ओके
क्यूरियोसिटी
ओके।
बहुत ज्यादा है पढ़ने के लिए उनके लिए ये सब है।
अच्छा अच्छा, हाँ तो आप मुझे मतलब वो आप शेयर कर दोगे तो मैं देख लूंगा
हाँ
आपका जो
डेफिनेटली।
प्रीवियस लेक्चर रहेगा। यूट्यूब यूट्यूब यूट्यूब, अच्छा हाँ ठीक है ठीक है।
और मैंने एक और नोट जेएस का भी लिंक शेयर किया डॉक्यूमेंटेशन का, वो भी आप पढ़ लो, उसमें उसमें लाइक अच्छे से दिया, लाइक मैंने वही पढ़ा है, लाइक मैंने और कुछ नहीं पढ़ा।
अच्छा। ओके ओके।
ठीक है, तो
सब्सक्राइब।
डॉक्यूमेंटेशन बेस्ट होता है। थैंक्स भाई। और हाँ, अगर तुम लोग को पसंद आएगा तो जस्ट अपवोट दे देना
हाँ
प्लेटफॉर्म
कर
पे।
दिया, वोट तो कर दिया आपको।
थैंक यू भाई।
अब नेक्स्ट सेशन कब स्टार्ट हो रहा है, मतलब कब रहेगा आपका?
नेक्स्ट में अभी आज क्या है, नेक्स्ट वीक लाइक मंडे ट्यूसडे, मोस्टली जो टाइम पे होगा वीकडेज में कभी भी, मतलब हो जाएगा लाइक नेक्स्ट 4-5 दिन में। एंड उसमें सिर्फ एक्सप्रेस करेंगे, उसमें हम लोग अच्छे से पूरा एपीआई बना देंगे, कर्ड
अच्छा।
एपीआई, मतलब वो
बाकी
सिर्फ
ये
काम
था
का
कि
होगा।
ये जो है ना कोड हीरो, इसमें प्रॉब्लम ये है कि अगर मैंने शेड्यूल कर दिया ना अपने उससे मान लो गूगल मीट से या फिर कहीं पे गूगल कैलेंडर से शेड्यूल कर दिया, क्या है, मेरे पास नोटिफिकेशन आएगा, तो बहुत बार नोटिफिकेशन आता नहीं है, और अगर कोई बंदा मान लो चेंज कर देता है तो फिर वो चेंज नहीं होता है उसमें, तो वो थोड़ा सा मिसमैच हो जाता है कि यार कब स्टार्ट हो रहा है, कब कौन सा इवेंट हो रहा है।
हाँ मैंने भी कल रखा था, फिर मैंने आज शिफ्ट कर दिया उसको।
हाँ हाँ, तो वो कभी मैं ना जैसे
हाँ
यार मुझे
वो,
वो कल परसों कोई सा इवेंट वो अटेंड करना, पर वो मिस हो जाता है फिर कि यार भूल गए, याद ही नहीं आया।
हाँ मैं हितेश से बात करता हूँ, हितेश सर से बात करता हूँ एक बार।
चलो चलो।
चलेगा, देखते हैं, उसका कोई इशू नहीं, बट हाँ लाइक अगले बार एक्सप्रेस करेंगे उसको, वो अच्छे से करेंगे फिर, मतलब सिर्फ एक्सप्रेस ही करेंगे। ठीक है फिर, लाइक इफ यू गाइस और कुछ होगा तो वी कैन डिस्कस है फिर बंद कर देंगे. Okay, so Yash, Priya, Gauri, and Sharindra, like thanks a lot for joining. You can connect with me on LinkedIn if you want to and ask any questions. बाकी तो thanks a lot. I guess तुमको कुछ तो value मिला throughout this session.
आपका वो नहीं है क्या ट्विटर पे? क्योंकि लिंक्डइन में बहुत कम एक्टिव रहता हूँ मैं, तो आप अगर वहाँ रहोगे तो
ट्विटर
फिर
पे
वहाँ पर
तो
ज्यादा
इतना
बात हो
नहीं हूँ
जाएगी.
मैं. ट्विटर पे आई एम देयर बट इतना एक्टिव नहीं हूँ. लिंक मेरे पास भी होगा नहीं.
अच्छा अच्छा, ठीक है ठीक है.
हाँ, चलो ठीक है फिर. बाय, गुड नाइट, हैव अ डे, हैव अ नाइस डे. डे इज गुड नाइट. So ठीक है, I'm ending the meet. Thanks a lot, Priya. Thanks a lot. Yeah, bye. Just close this recording. हाँ.